The race is on to get to net zero by 2050, but how are aeroplanes going to do that? Apparently one way is to improve blade design. I'm about to meet an expert who's going to explain all of this to me. So Abby, a really crucial part of building better jet engines is to understand how they work in the first place. So can you take me through a quick whistle-stop tour of the blades involved in a jet engine?
At the front over here you have the fan blades, and that's sort of the first part of the engine, and that's what you'd see when you're going on holiday and you're just boarding the plane. Just behind it you have the compressor. So the compressor basically compresses the air, so that generates more energy for the combustion process. And then after the combustor you have the turbine, which essentially expands the air, blows the air out, and that then goes through the nozzle at the very back. So that's basically how a gas turbine jet engine works. The aviation industry has been a super important part for globalization, but now the industry is actually facing more and more challenges.
And so your job here at the Whittle Lab is to make flying as environmentally compatible as possible.
A really big part of the Whittle Lab and what we do is our ability to rapidly generate a wide range of geometries and test them. By being able to do this very quickly, we can get more answers quickly and actually determine what the sort of right designs that we should be focusing in on are. Here we have a rotor blade. This would be used in current designs for gas turbine jet engines.
That's nothing to do with the big fan blades that you see on the outside of an engine, right?
Is behind that big fan blade.
What I'm getting from Abby is that blades are designed very differently in order to take air and do things with air and get air to behave in a certain way because of the way it's designed. Abby, it's quite normal to go from designs on a computer to sending it off to print, essentially, where you manufacture objects that you create. What's an example of actually designing and then sending off to a printer? Like, is this what we're looking at here?
Essentially, here we can design the sort of three-dimensional blade profile and generate a file which is then ready to be machined into an actual blade like this one. You would get a file which is ready for manufacturing, and we'd send that file over to our 5-axis machine, to this, and cuts away at the metal to give us a blade like that.
Yeah. Can we actually see the place where it actually gets manufactured?
We'll put this block of aluminium into this 5-axis machine, close the door, and let the magic happen. This rig is actually called the Gibbons. It simulates a compressor that will be inside an actual gas turbine jet engine. And what we have inside it are these blades that we've just manufactured in-house. This simulator is basically simulating how a compressor works, and compressors basically suck air. What happens is the air goes inside, and then we get to take all the great measurements using these probes.
So all the experiments happening right in the centre?
Yeah, exactly, right inside this. It goes through, we get to take all our great data, and then it comes out.
I'm desperate to look inside this. Not what I was expecting to see, because they are small.
So what we're seeing here is actually twice engine scale. So the engine blades are half the size of this. Because it's bigger, it's easier to measure.
Yeah. So this would have actually been spinning at 250 miles per hour when it's actually working.
So in each engine you would have about 6,000 compressor blades.
I can't believe that there's so much going on, and when you just look at a fan or look at an engine sort of straight on, it feels like there's just a fan. But after seeing this, that is so not the case.
What we want to do is make sure that we have good engine designs, good blade designs, which limit how often and how much these unwanted flow mechanisms take place. So we manufacture these in-house. That's all part of sort of rapid testing, because if we can make them in-house, then we can test more and more.
Abby's taking me all around this magnificent lab. It is a gigantic space full of huge gas turbines, but also the future of aviation, where everything is going electric.
So what we're doing here is some flow visualization. Now, flow visualization is a really great experimental technique for determining what sort of flow structures are present. Now they're all spinning, and I'll put the wind tunnel on so we can get some air through.
Definitely on the wind tunnel.
Yeah.
So was the hope that you might see horizontal lines?
So sometimes it's really hard to get flow visualization right. It's a bit of a black art. We're getting sort of strictening regulations on carbon emissions because we really want to reduce the impact that aviation has on our environment. So it's really important that we're investigating new ways of propulsion, but also really improving current designs.
Who would have thought there are that many blades in a jet engine? And if you thought that was cool, you should watch the film on Kat Gardner, who will tell you all about combustion.